My name is Bilal Yassin. My research focuses on switched reluctance motor control for electric vehicle applications. Although SRM is low-cost and robust, it suffers from high torque ripple and noise. This graph shows torque ripple in SRM. The torque is not smooth, which causes vibration, noise, and reduced performance. To solve this problem, I propose an AI-based real-time control system using a full bridge converter. This is my MATLAB Simulink model. It consists of three main subsystems: SRM model, converter, and AI controller. AI-based real-time torque ripple minimization in SRM using full bridge converter. Problem: high torque ripple, noise, nonlinear control, lack of real-time AI implementation. Objective: reduce ripple less than 10%, develop real-time AI control, optimize converter. Methodology: SRM modeling, converter design, AI controller, real-time testing. Expected results: improved efficiency, reduced noise, practical EV application. The SRM model is based on a lookup table that represents nonlinear characteristics between flux, current, and rotor position. The full bridge converter controls current flow using IGBT switches. It enables better control compared to conventional converters. The AI controller combines neural networks and fuzzy logic. It predicts and adjusts current in real time to minimize torque ripple. This result shows that torque ripple is significantly reduced using the proposed AI-based controller. This research provides a real-time, low-cost solution for SRM control, making it suitable for electric vehicles.